This is one of the most disliked places on Earth, a desert almost devoid of human life. And yet here, an incredible feat of engineering is being built that is nothing short of miraculous. In the heart of Chile's Atacama Desert, on a mountain peak 10,000 feet above sea level, construction is set to begin for the world's largest telescope. This telescope, as tall as 40 times the Leaning Tower of Pisa, enables us to look at some of the planets in our cosmos with an intensity of as much clarity as 5,200 times of that of our naked eyes. An image is crisper by 15 folds than what Hubble can see. The world's largest telescope, built upon the driest place Earth, is nothing short of miracles. This place, the Atacama Desert, is the driest on Earth next to Antarctica. There are areas that never saw a drop of rain since recorded history. Based on its uniqueness, the Atacama seems to be the surface of another planet, an alien planet, which explains why the European Space Agency used this location to test its Mars rover. Located 1,300 kilometers from Chile's capital Santiago and 130 kilometers from the nearest city, this desert peak is the site for a remarkable project that will offer humanity a view of another world in space. The European Southern Observatory, ESO, is building a huge telescope here, called the Extremely Large Telescope, ELT. While construction is still underway, it's easy to understand why this telescope is deserving of such a name. The telescope will feature a giant mirror of 39 meters in diameter, the largest ever created in this case, and it will be 4 times any size built so far. This mirror can gather 100 million times more light than the human eye, as long as no speck of dust falls on it. To protect it, the telescope will be housed in a large steel dome weighing about 6,000 tons, or the weight of 2,400 pickup trucks. The dome will have 2 massive doors that will remain closed during the day. That makes it fit the Statue of Liberty hole into it, and within can be built the full pitch size of a football field. Under the dome, there is a high-tech platform to make the telescope rotate 360 degrees, making it very easy to observe any part of the sky at night. One could hardly imagine how such construction of this complex project began in this remote and arid location, away from any population, not even with roads, electricity, or water. It is from scratch that the team had to begin, from nothing, building everything from ground zero. The ESO is a European intergovernmental organization with 16 member countries and first explored several locations across Europe, but finally settled on this location in South America. According to the head of ESO's project, there are several reasons why this particular location was chosen. A major factor was the area's ability to have cities nearby. Light pollution remains a serious problem in these areas. City lights do not allow for clear observation of the sky, and even the clouds reflect light, much brighter than the faint light of distant stars. The image generation could be compromised, but such locations are also available in mountain ranges across Europe. So why did the ET select the South American location? It's not enough to avoid light pollution. It also requires a clear sky. Europe generally has a tropical climate, leading to frequent cloud cover. However, the Atacama Desert, one of the driest places on Earth, enjoys 320 clear days out of 365 annually, making it ideal for observing distant galaxies. In 2010, the ESO team tested various locations and found Atacama's site to be the best. They selected the 3,000-meter-high mountain, Cerro Armazon. The challenge was that, unlike other mountains, it had a very steep peak, making construction impossible in its natural state. Thus, the summit had to be leveled to create an area the size of 7 football fields. Imagine creating such a huge flat surface at an elevation of 3,000 meters. This was a difficult task, dangerous work, where they had to use explosives. The top of the mountain was drilled with explosives detonated remotely, removing the upper 100 meters of the peak, displacing 4.7 million cubic meters of earth, enough to fill 1,911 Olympic-sized swimming pools. Finally, after clearing the rubble, the mountain's top was leveled and a road was built to access the peak. But that is where it all started. A major issue now occurred. Sinkholes started forming throughout the newly leveled ground. The engineers realized that this explosion damaged the core of the mountain and cracked the rocks and soil, causing them to shift. In response, the engineers vibrated the Earth in an attempt to settle it down so that any and all sinkholes formed simultaneously. After several months of work, the ground was stabilized enough to lay the foundation of the telescope. This area is a seismically active region, prone to earthquakes. To safeguard the expensive components of the telescope, the foundation was separated from the dome, and hydraulic shock absorbers were placed between the two to shield the telescope from tremors. The foundation was completed by 2023. The next thing was to build the impressive steel dome. The structure was built in parts at the base camp and transported up to the mountain using remote-controlled trucks. Once at the summit, cranes assembled the pieces, much like connecting Lego blocks. The road network up to the ET site already existed because ESO's Very Large Telescope, VLT, is located 20 kilometers away. The roads were extended to reach Cerro Armazon, where the largest telescope in the world is being constructed. The 39-meter-wide mirror, which will control the telescope, is currently being installed inside the dome. The mirror consists of 800 small pieces, and its job is to collect and multiply light from space, which is then directed through secondary mirrors, M2, MM3, and M4 to sharpen the images. Powerful lasers mounted on the dome are used to create artificial stars in the atmosphere, providing a reference point to monitor real-time atmospheric conditions and enhance the clarity of the images captured by the telescope. The light is being distorted or blurred due to the atmospheric distortions. Once these distortions are detected, the blur in the telescope's image can be easily removed. This process is called adaptive optics. After clearing the blur in the image using M4, the light moves to M5, where the image is further refined and sent for processing. While we've discussed the telescope's impressive capabilities, the biggest question remains. Will the ET telescope be able to capture direct photographs of exoplanets outside our solar system, planets that may have the potential for life? We can now, using these exoplanet graphs, determine the composition of their atmosphere, which may reveal whether there is water, carbon dioxide, oxygen, or even life forms causing pollution like on Earth. Because of the ET's massive mirror, it will gather more light, and we can see even the early stages of the universe. Light travels at a fixed speed and cannot travel faster than that. This principle allows us to view the past of the universe. For example, when the sun rises, we're actually seeing the sun's past because its light takes approximately 8 minutes to reach Earth. The Hubble Space Telescope can see 13.4 billion years into the universe's past, capturing light that left the universe 13.4 billion years ago and has just reached Hubble now. Compared to that, ET's 39-meter-wide mirror can observe 100 million years before Hubble because it is capable of observing from 1.35 billion light-years away, whereas scientists have determined that it took the Big Bang 13.8 billion years to birth our universe. This signifies that ET can capture the images 300 million years into the creation of the universe. Also, though ET is very large, it will still be the largest optical telescope. But radio telescopes, such as the one in GoldenEye, use big dishes to detect radio waves and then produce images through computer processing. ET will still be the largest telescope for direct observation. The cost for the estimated expense of ET is going to be a whopping $1.6 billion, 136 billion rupees, equivalent in cost to the building of the world's tallest building, Burj Khalifa. According to experts, the construction of ET is expected to be completed in 2029. It may eventually have the final answer to one of the biggest questions. Are we really alone in this universe, or could life possibly exist on an Earth-like planet thousands of light years away? We hope you like it and share it. Love you guys. Thanks for all your comments. See you in the next awesome video.